Good day once again, everyone. My name is Owolemi John, and today we are looking at a topic which is structure and bonding in chemistry. Structure and bonding in chemistry. And the subtopic we have under this topic is properties of ionic and covalent compounds. At the end of today's class, we are going to learn the following objective: ionic and covalent compound. So we are going to do a kind of a little revision on ionic and covalent compound. We are also going to talk about the properties of ionic compound, properties of a simple covalent compound, properties of giant structure, and diamond and graphite as a case study. Ionic and covalent compound. What is an ionic compound? So we just want to kind of revise an ionic compound and remind ourselves what ionic compound is. Ionic compound is a compound that is formed when there is a transfer of electron from one atom to atom of another element. So the atom that is transferring electron is usually metal, while the atom that is receiving the electron is usually non-metal. Take for instance the reaction between sodium and chlorine. Sodium atom has one electron in its outermost shell, and based on the fact that every atom wants to have a kind of a stable configuration like that of group 8, it is easier for sodium to donate one electron from its outermost shell. Therefore, sodium is going to donate its outermost shell electron to chlorine. So sodium will become positively charged because the number of protons is now more than the what? Number of electrons, based on the fact that sodium has lost an electron. Don't forget that an atom is electrically neutral when it has not gone into any form of reaction. So sodium has lost an electron. Sodium will be more of a what? Positive charged particles. Number of protons will now be more than the number of electrons. The chlorine atom that is accepting the electron that is transferred from chlorine and sodium atom, the chlorine atom will become negatively charged. So that's how, and the compound formed now between sodium and chlorine is now known as what? Ionic what? Compound, because there is transfer of electron. So another example is the reaction between oxygen and magnesium. So magnesium will become what? Positively charged, while oxygen will become negatively charged. So there is transfer of two electrons from magnesium atom to oxygen atom. Now let's quickly revise what covalent compound is, or how covalent bonds are formed. In covalent bonding, there is sharing of electrons. Two reacting atoms come together and share their what? Electrons. So the electron in their outermost shell. It is possible that the two atoms are just sharing what? One electron. When this happens, we call it what? Single covalent bond. When the reacting atoms, each of them contribute one electron each. Okay? We call it single covalent bond. But if each of them contribute two electrons, we call it what? Double covalent bond, triple covalent bond, and so on. So covalent bonding have to do with what? Sharing of electrons, just like you can see in this picture. So, but the main part of what we want to look at in this topic is properties of substances, properties and structure of different substances. So we are starting with ionic substances. What are their properties, and why is it that they have this specific property? Number one, ionic compounds usually have a high melting and boiling point. We want to look at the reason why ionic compounds have high melting and boiling points. When an ionic compound is formed, when there is transfer of electron from one atom to another atom, so the molecules, that is the ions that are formed as a result of that ionic bonding, they will arrange themselves in a regular repeating pattern known as what? Lattice. Okay, just like we can see in this diagram. The yellow color sphere represents sodium ion, while the red sphere represents chlorine ion. Therefore, there is going to be a kind of a force of attraction between the atom of sodium and atom of what? Chlorine. And you can see the way they are arranged. They are arranged in a regular repeating pattern. That regular repeating pattern is known as what? Structural what? Lattice. So ionic compounds have structural lattice, and there is a force holding one particular ion to the neighboring what? Ion. Like look at this ion now. There is a force holding this ion to this ion, There's a force holding this ion to this ion. There's a force holding this ion to this ion. And there's a force holding this ion to the what? Ion below it. Therefore, like one ion, we have, and there's another, we have like about 1, 2, 3, 4, 5, like 5 other ions attracted to it by strong electrostatic force. Now, if you want to melt a substance, let me tell you, the first thing that will happen is that you have to overcome the bond, the force, holding the molecules of that substance together. So, for you to melt ionic compound, you have to overcome all the electrostatic forces holding its molecules together before the substance will be able to melt. So because of the presence of this strong electrostatic force of attraction between the ions of an ionic compound, therefore, ionic compound will have what? High melting point, because we require higher energy that will overcome that strong electrostatic force. So this is why ionic compound have high melting and boiling points. I think you get my point. So why is it that ionic compounds have high melting and boiling points? Your answer should be that what? It requires higher energy to overcome the strong electrostatic forces of attraction, not just one force, forces of attraction between the molecules of what? Ionic compound in all directions. Okay, so all the oppositely charged ions, like sodium positively charged ion and chlorine negatively charged ion, there is a force of attraction holding them together. So those forces of attraction holding one atom, one ion to the neighboring ion, we have to overcome that force. Therefore, ionic compound will have high melting and boiling point. So this is the reason behind ionic compound having high melting and boiling point. So the next thing is that a large amount of energy is needed to break these many strong bonds. So that's what we are saying here. So that's why ionic compound have high melting and boiling point. I think this point is clear. Okay, the next thing is ionic compound also conduct electricity when melted or dissolved in water. Ionic compound conduct electricity only on 2 conditions. What are these 2 conditions? When the ionic compound is in molten form, or when melted, or when dissolved in water. This is the only 2 conditions in which ionic compound will conduct electricity. If an ionic compound is in solid form, it will never conduct electricity. And the reason is because what? The positive and the negative ion are fused together in a what? In a solid, and they are unable to move. Ionic compound will only conduct electricity when its ions, the positive ions and the negative ions, are able to migrate, are able to move. We call them what? Mobile ions. So if the ions are not mobile, there is no way they can conduct what? Electricity. Therefore, ionic compounds are good conductor of electricity. In fact, they are called electrolytes. An electrolyte is a substance that conducts electricity when in solution or in molten form. So ionic compounds are what? Electrolytes in molten form or in solution form, because they consist of what? Mobile ions. Okay, so when you dissolve an ionic compound, this is an ionic compound, but when you dissolve it or you melt it, the ions, the positive ions that are joined together here, they will now be free to migrate, to move from one point to another. So, and when this happens, therefore they can carry what? They have charged particles, and therefore they can transmit what? Electricity. They can conduct electricity in molten or solution form. I think this point is clear also. Properties of covalent substances. Now we want to look at properties of covalent substances. We can classify covalent substances into 2. We have small molecules and we have giant molecules. Now we are looking at small molecules of a covalent compound. A compound that is formed like a hydrogen molecule. When 2 hydrogen atoms come together to share electrons, then we are simple molecule. So in simple covalent compounds, they have relatively low melting and boiling points. Don't forget, when we are talking about melting point and boiling points, the more you increase the temperature of a substance, that means when you apply heat to a substance, you are increasing the temperature. Now, the essence of that heat you are applying is to break the force of attraction holding the molecules of that substance together. So the higher the temperature, the more the quantity of heat that has been applied, because temperature is a measure of the degree of hotness or coldness of a body. So the temperature measures the amount of heat energy you have applied. So if the temperature is very high, it means that you have applied a very high amount of heat that is enough to break the what? The bond holding the particles or the ions or the atoms of a particular compound together. So don't forget, for you to melt a substance, I said what? Bonds need to be broken. So if these bonds are not broken, there is no way that a substance will melt, or there is no way a substance will what? Will boil. Okay? So for small molecules, the force holding, the covalent bond holding their atoms together is very weak. Therefore, you need a small amount of what? Heat energy. If there is small amount of energy, that means there is what? Lower what? Supply of temperature. Therefore, that is why small molecules, they have what? Low melting points. The temperature at which they will melt is very low. The temperature at which small molecules will boil is very low. I think you understand that point. So they have low melting and boiling point. The summary is here. Because of the intermolecular force are overcome on melting and boiling, and these are weak forces. So the intermolecular force of attraction holding the atoms together in a small molecule is very weak. Therefore, you need small amount of energy to break those what? Bonds or the forces. The bigger the size of the molecule, the higher the melting point and the boiling point. The bigger the size of the molecule, the more the what? The higher the melting point and the higher the boiling point. This is because intermolecular forces increase with the size of the molecule. So when the molecule is getting bigger, it may be a complex molecule, therefore the what? Intermolecular forces is also what? Getting stronger. Small molecules, they don't conduct electricity. Now, anytime you hear maybe a substance does not conduct electricity, the first thing your mind should go to is because what? There are no charge carrier, or there's nothing like what? Free electron to conduct the electricity. So you don't need to think. A substance does not conduct electricity, yes, maybe because it does not have what? Free electrons, the localized electron, or it's not an electrolyte that contains what? Ions to carry the electrons, or to carry charges. So take note of that. So they don't conduct electricity. Small molecules don't conduct electricity because the molecules have no overall electric charge. They have no free electrons or ions, so they don't have charge. That is why molecules, small molecules or small covalent compounds do not conduct electricity. Now we are looking at giant structure. Now, giant structure, we have giant covalent compounds. They have high melting and boiling points. Don't forget they are giants. They are actually product of polymerization of small molecules. Because they have a high melting and boiling point just because of what? All the atoms are linked by what? Strong covalent bonds. Okay? All the atoms are linked because just imagine these two hands they are holding each other. Another hand comes holding this one, holding like that. Okay? We are going to form a network of what? High bond, strong bond. So, giant covalent compounds have high melting and boiling point because what? All of the atoms linked by what? Strong covalent bonds. Now, let's talk about polymers. Polymers are solid at room temperature because intermolecular forces increase with the size of the molecules, and polymer molecules are very large. Polymers are usually solid at room temperature. Okay? Polymers are formed by a process known as polymerization, where small monomers, that is small molecules now, come together to form a larger molecule. We call it what? Polymerization. And the larger molecule they form is known as what? Polymer. Okay? So they are usually what? Solid at room temperature because the intermolecular force increases with the size of the molecules. So as the molecules are getting closer together, forming larger molecules, the intermolecular force of attraction between the what? Neighboring molecules increases. Is that taken now? The intermolecular forces of attraction increase. Okay? Therefore, molecules are usually what? Polymers are usually solid at room temperature. Now let's talk about diamond. Diamond is an example of giant structure. Diamond is very hard. It has very high melting and boiling point. and does not conduct electricity. Now we want to see why diamond does not conduct electricity, why diamond is hard, why diamond have high melting and boiling point. Now look at this structure. This is the structure of diamond. All the structure you are seeing here, they are structure of diamond. So here is the breakdown of the structure of diamond. If you can look at this carbon atom now, this is a carbon atom. I'm using my pointer to cover, okay, carbon atom. So this carbon atom is bonded to, let's count. What are the carbon, how many carbon atoms do we have around it? We have 1, 2, 3, 4. Each of the carbon atom in diamond is bonded to what? 4 other carbon atoms covalently with strong covalent bond. And this is why diamond is very strong. So because a particular carbon atom have other 4 carbon atoms holding it. So for you to break the bond, you require what? Higher energy. And I think diamond is, up to today, diamond is still the hardest known substance because of this nature of how diamond is formed. Okay? Carbon atom has 4 electrons in its what? Outermost shell. You can see now, diamond uses what? All these 4 electrons in its outermost shell to form bonds with neighboring carbon atoms. Therefore, diamond will never conduct electricity. Why? Because there is no free electron left. It has used all its 4 electrons that it has in its outermost shell to form what? Bond with the neighboring what? Carbon atoms. So this is why diamond does not conduct electricity, and it's also the reason why diamond is hard, and diamond will have high melting point and high boiling point, because what? You will require higher force to break down the force holding one particular carbon atom to the 4 neighboring carbon atoms. So this is the structural representation of diamond, and this also represents diamond. You can see the sphere at the center is the carbon atom. All the spheres represent carbon atoms. So each of the sphere is connected to what? 4 other spheres. So that's why diamond is hard. That's why it has high melting point, and that's why it has what? High boiling point. And it does not control electricity because there's no free electron left. It has used what? All the electrons in its outermost shell, on the outermost shell of carbon, which is 4, to form bonds. So there's no free electron. So a substance that does not contain the localizer of free electron will never conduct electricity. So let's look at graphite. Graphite is just also like diamond. Graphite and diamond, they are allotropes of carbon. Allotropy means the ability of a substance to exist in 2 or more forms in the same physical state. So diamond and graphite, they are the crystalline allotropes of what? Carbon. Graphite is very hard, but it's not as hard as diamond. It has high melting point and boiling point, not as high as that of what? The boiling point and melting point of diamond. Graphite conducts electricity. So we want to see, why is it that graphite is hard? And why is it that graphite have high melting point and boiling point? Because in a graphite structure, look at this. Look at my cursor here. Each of its carbon atom is bonded to 3 other carbon atoms. Unlike diamond, that what? Each of its carbon atom is bonded to 4 other carbon atoms. But in graphite, each of its carbon atoms is bonded to 3 other carbon atoms. And don't forget that a carbon atom will have 4 electrons in its shell. So for one carbon atom to be bonded to 3 other, that means in graphite, carbon only uses what? 3 out of its 4 electrons to form bond. 1 electron is free, isn't it? Now, because of that bonding between 3 other carbon atoms, that's why graphite is hard. But it's not as hard as what? As diamond. That is why graphite will have high melting point and boiling point, because it has what? One of its carbon atoms is bonded covalently with 3 other carbon atoms. But graphite will conduct electricity because what? It has free electrons. It only uses what? It uses 3 out of its 4 electrons in the outermost shell of carbon to form bond. Therefore, graphite will have what? Free electrons. Each carbon is bonded to 3 other carbons by strong covalent bonds. So it forms layers of hexagonal rings. with no covalent bond between layers. So there are free electrons in what? In graphite. Okay, because it's only one carbon atom is bonded to 3 other carbon atoms. This is a layer of graphite. What we are seeing here is a layer of graphite. Just like this layer, we will have another layer below it. Okay, so graphite exists in layer. The bond in a particular layer is strong. Is that taken now? But the bond in between 2 layers, is that taken, is weak. Therefore, graphite can easily slide over one another. That is why graphite can mark on the paper. So graphite occurs in layer. So that is why graphite is also can mark what on paper, because it will be soft. Because of that, what the weak bond holding the layers of graphite together. So if you look at what is written here, there are no covalent bonds between the layers. Okay, this is a layer now. But this layer you are seeing, another type of this layer will now occur under it, and so on. So there are no covalent bonds between the layers, and so the layers can easily slide over each other, making graphite soft and slippery, and an excellent what? Lubricant. So this is the reason why graphite is soft for writing on paper. The substance you have inside your lead pencil is a graphite. Okay, so that's why graphite can be used to mark paper, to write on paper. That's why graphite will be slippery, and it will serve as a what? A good what? Lubricant, like oil. Okay, because of what? It has layer. It exists in what? Layers. Now, graphene is strong, light, and an excellent conductor of thermal energy and electricity, because graphene is just a layer of what? Of graphite. Okay, is a single layer of graphite. So one single layer of graphite is what? Is graphene. So graphene also we have what? The property of graphite, which is ability to what? Conduct electricity. So graphene does not have layers. So graphene is not slippery. Graphene is not a lubricant. Okay, but graphene will conduct electricity because it is just a layer of what? Graphite, which have what? Free electrons. Now we have another compound here, which is fullerenes. Fullerenes, e.g. carbon nanotube, are extremely strong and are excellent conductor of thermal energy and electricity, because they have strong covalent bond and free electron. If you look at this, this is a carbon atom, 1, 2, 3. 1, 2, 3. Each carbon atom, just like in graphite, each carbon atom is bonded to what? 3 other carbon atoms in fullerenes. Okay, so that is why fullerene will be what? Will be able to conduct electricity, because it has what? The localized free electron. So this is the summary of ionic compound, characteristic of ionic compound. Okay, so you can go through it. They are made of positively and negatively charged ions. They have high melting and boiling point because of strong electrostatic force of attraction between the ions. So this is the summary of everything. They are soluble in water, but insoluble in organic solvents such as ethanol and petrol. Okay, that's an addition. In aqueous solution or molten state, they conduct electricity because the ions are free to move. They are non-volatile and generally solid at room temperature. So this is the summary of all the characteristics of an ionic compound. Now let's look at the characteristic of covalent compound. They are made up of molecules. Okay, they are usually occurring as what? Made up of molecules, series of molecules coming together to form covalent compound. They have low melting and boiling point because of the weak force of attraction which holds the molecules. So this particular number 2, please take note, is talking about what? Small molecules, not giant molecules. So giant molecules like diamond, they have a strong covalent bond. The molecules are bonded, or each carbon atom in a diamond is bonded to what? Covalently with 4 other carbon atoms, and the covalent bond here, they are strong. Therefore, giant molecules like graphite and diamond, they will be hard. Although the reason why we say graphite is soft, take note, is because graphite exists in layers. Now, number 3, they are insoluble in water but soluble in organic solvents such as ethanol and petrol. So covalent compound, they are insoluble in water, unlike what? Ionic compound, but they are soluble in what? And organic solvents. So we call them, organic solvents are also known as non-polar solvents. So they do not conduct electricity in solid or solution form. They do not conduct electricity in solid or solution form because they are made up of molecules. But giant molecules like graphite and graphene, they conduct electricity because of the presence of what? Free electrons. Because they only use 3 out of the 4 electrons in carbon atom to form bond between corresponding carbon atoms. So take note of that. So when we state some properties, it's not for all covalent compound, okay? Take note of that. They are generally volatile. So covalent compound, especially the smaller covalent compound, they are what? Volatile. So the summary of everything, that is a derivation of some of the terms we have used in this topic. We have fullerene. Fullerene is an allotrope of carbon, so it's a form of carbon that can exist in a cage-like or tubular structure based on hexagonal rings of carbon atoms. Okay, fullerene is just like what? Graphite also. Each of its carbon atom is bonded with what? 3 other carbon atoms by strong covalent bond. So it has free electrons. Fullerene can conduct what? Electricity. Delocalized electron. Bonding electron that is no longer associated with any one particular atom. So these delocalized electrons, we can see it in what? Metal. We can see it in metal. We can see it in graphite and graphene and fullerene. Giant covalent structure. So giant covalent structure, these are polymers that are formed by the combination of what? Smaller monomers in order to form a bigger monomer by a method known as polymerization. So we have intermolecular forces. Intermolecular forces is the force holding one molecule to another molecule covalently to another molecule. So the force bonding a particular molecule to another molecule is known as what? Intermolecular force of attraction. So diamond. Diamond is a form of carbon, or is an allotrope of carbon that in which each of its carbon atom is bonded covalently to 4 other carbon atoms. Therefore, the diamond is strong. It has high melting point and what? High boiling point. But diamond will not conduct electricity because there is no free electron. Graphite is another form of carbon. It is an allotrope of carbon, crystalline allotrope like what? Diamond. Okay. In graphite, each of its carbon atom is bonded to what? 3 other carbon atoms. Therefore, it only uses 3 out of its 4 electrons around each of its carbon atoms. Therefore, it has free electrons that can transmit what? Or conduct electricity and heat. But graphite exists in layers. Okay? So one particular layer is resting on another layer. So the bond in a particular layer is what? Covalent bonds that are strong. Okay? But the bond holding one particular layer to another layer is very weak. So that is why graphite can mark on a paper. The substance you have inside your pencil is made of graphite. And that's why graphite is soft and can be used to what? For making lubricant. So take note of that. Graphene is another form of what? Carbon. Graphene is just a layer of what? Of graphite. Therefore, it means that each of its carbon atom is bonded covalently to 3 other carbon atoms, and that is why graphene can what? Conduct electricity just like graphite can conduct electricity. Ionic lattice. So ionic lattice, we talk about what? The arrangement of ions of ionic compound in a kind of alternating way, regular repeating pattern of arrangement. So this is what we refer to as what? Ionic lattice. So these are the evaluation questions we are going to take today. So we are going to take number 1. If the size of a small covalent molecule increases, what effect does this have on the boiling point? Generally, small covalent compounds, they have what? Low melting and boiling point. When the size of a small molecule increases, the melting and boiling point will also increase. Explain why ionic compounds have high melting and boiling points. It's because of the strong electrostatic force of attraction holding the what? Ions together, holding the alternating ions together. So that is why ionic compounds have high melting and boiling points. Explain why a ionic compound can conduct electricity when melted or dissolved in water. Yes, because the ions becomes what? The ions become mobile when melted or dissolved in solution. So that is why a ionic compound can conduct electricity when melted or dissolved. What form do ionic compounds take? They have a kind of lattice arrangement.